Hello, dear students. Hope you all are doing well at home. Okay, today we're gonna start with the ninth class chapter called Gravitation. Okay, beta, you're gonna once again read this chapter in your 11th class, but with a higher concept. Okay, beta, what you're gonna study in your 10th class, you'll again repeat it. You'll learn some more things in 12th class. In short, beta, whatever you will learn in 9th, 10th, 11th, 12th, that will be in your NEET or JEE examination. That means right now, right from here, your preparation starts. Okay, beta, I would like to go back to the topic with a beautiful saying, when there is a will, there is a way. Okay, beta, if you have will in your heart, you will definitely find a way to achieve your goal. Okay, beta, with that great thought, we'll start today's topic, that is gravitation. What is gravitation, beta? Gravitation is a force. Okay, beta? Gravitation is a force experienced by a mass. Okay, beta? Whenever there is a mass, for example, I have this pen in my hand. It's having some mass. What's the definition of mass? Anything that occupies space, or you can say the amount of substance in an object. Right, beta? That is mass, right? So, what is mass, beta? Mass, I told you, it is the amount of substance in an object, right, beta? So, like anything is having mass, I'm having some mass, this pen is having some mass, you are having some mass. But what is gravitation? It's a force that one mass exerts on another mass. I will make it clear by a simple example. For example, this is a mass, right, beta? I'm also a mass, right? I'm attracting this mass towards myself. Right, beta? There's a property of matter, there's a property of mass. Whenever two masses come in contact, they put a force on another mass so that they try to attract it towards itself. For example, you only know about the gravitation. The thing you know about the gravitation, the thing that comes in your mind, whenever I drop anything from my hand, like this, I drop anything from my hand, it drops towards the earth. Why, beta? You will say gravitation, because of gravitation. Right, beta? Why? I'm also mass. I'm putting some force. I put some force on it. I try to attract it towards me, or this pen tries to attract me towards itself. It's not going towards myself, nor I am going towards this pen. But what is happening here, beta? When I'm releasing this pen from my hand, it's going towards the ground, beta. That means Earth is attracting it. One mass is attracting the second mass. That means, beta, same is the case with me. When I am standing on ground, Earth exerts some force on me. It tries to pull me towards itself. Okay, beta? This force is called as gravitation. Okay, beta? What is the force of gravitation? If I am having a mass, this is the mass. Okay, beta? Let it be M1. There is second mass, M2. Okay, beta? What I'm trying to explain, whenever there are two masses in contact, this mass and this mass, they are in contact, they will do one thing, beta. They will try to pull each other towards itself. Okay? There will be a force between them. There will be an attractive force between them. The force will try to come closer. It will try to catch another mass. For example, this mass M1 comes in contact with M2. This mass M1 will try to attract this mass M2. And same is the case with M2. This M2 will try to attract this mass M1 towards itself. Right, beta? So, if I took two masses M1 and M2, for example, there is a distance of R between them. Okay, beta? There must be some distance. If I'm taking one mass here, there is some distance between them. So, they are attracting each other. Right, beta? So what we understood by this thing, that whenever two masses come in contact with each other, they attract. For example, if you are standing in front of me, beta, you are standing in front of me. You are having some mass. I'm having some mass. Right, beta? You are having mass and I'm having mass also. So what happens here, beta? I will try to attract you towards myself. Okay, beta? Same is the case with you. You will try to attract me towards yourself. Why is this thing happening? Why is this thing happening, beta? It's happening because it's the property of mass that it attracts second mass, which is kept in contact with it. Okay, beta? We can explain this thing by, I told you, the Earth's gravitation. It's not the gravitation is limited to Earth only. It's not like that. I'm attracting you, you are attracting me, but this force is negligible. This force of attraction is negligible. So we're not attracting each other, right, beta? But with the earth, the case with the earth is that is a big body. We will explain it in the numericals also. Earth is a big body and it's attracting some little body. So definitely this force will be more. How this more force will be more, we will explain it. Okay, beta? So I told you what is gravitation is the force between two masses. One mass tries to attract another mass. For example, it's not only with earth, moon has a gravitational field. Moon has a gravity. It tries to pull an object which is placed in contact near to the surface of moon. Solar system, Jupiter, Saturn, they have their own, they are having some mass. If they are having mass, they are having the force of gravity between them. That means the planets which are in contact, which are in solar system. This is sun. This is planet Earth. This is some another planet. So this planet is also attracting Earth. Same is the case with sun. Sun is attracting Earth towards itself and Earth is attracting sun towards itself because they are having mass. So beta, I would like to conclude by saying if there are any two masses, what will they do? They will try to attract each other. So beta, there's a property of this force which is called as gravitation. What happens, beta? This force is always attract you in nature. That means it will always attract each other. What is this gravitational force? This is always attract you in nature. They will never repel anybody. For example, two masses. This will not pull this or push this mass away from itself. It will never do it. Whenever the force of gravity, whenever two masses come in contact, it will try to pull it towards itself. This is the first property of the gravitation. What happens? It attracts the other mass. So beta, we concluded whenever there are two masses, they will always attract each other, Second property, beta, this force of attraction. For example, you are standing in front of me and I am standing at some distance from you. Okay, beta, I am exerting some force on you towards myself. Okay, beta, and you are doing same thing. Is the property of mass that they attract each other. But this attraction, does it depend on medium? For example, right now, the scenario I told you, here you and me are separated by a distance and the medium here, that is air, right beta? The medium here is air. What will happen if we both will go into the river? Do I attract you with the same force in water? If we both are in water, we try to calculate the force when we are in the medium of air. When you are standing in the classroom, I'm at the classroom, I'm at a distance from you, I'm attracting you with some force. Will this thing happen in water also? Yes, this thing will happen in water also, because I told you this force is always attract you in nature. It doesn't depend whether you are in water, whether you are in kerosene, whether an object is in kerosene or some oil. It will not depend on the medium. So the second property I told you is beta. This force, that is this gravitational force, it does not depend on medium. It does not depend on medium, beta. That means it will be same everywhere. Whether you are in air, whether the two bodies, the two masses are in river, in water, or in kerosene, or in petrol, whatever the medium is, the force of attraction will be same. It does not depend on the medium. Two properties, right, beta? The third property is an important property, beta. You have two masses. This is M1, this is M2. You are having two masses, M1 and M2, separated by a distance R, right, beta? Separated by a distance R. You can see this thing. This mass attracts M2. This mass attracts this mass. Or vice versa. This mass attracts this mass. But beta, think one thing. This mass is attracted towards another mass. We can we understood. It will attract it. But beta, it can attract it in this direction also. It can attract it in this direction also. But beta, the property here is that it always attracts the another mass center to center. That means the force of gravity between two particles is from center to center. For example, this is a circular body. Whatever its center is, from that we have to measure the distance to the another body. Right, beta? It always, the force of attraction between two bodies is at the axis of center. Right, beta? It will not attract it by this direction or this direction. This will always get attracted towards it by the line joining the center of the two masses. Is this clear, beta? Is this clear? So we conclude that the force of attraction or the force of gravity between two masses is the force that one mass exerts on another mass to attract it towards itself. So what is force of gravity, beta? It is always attractive in nature. One mass attracts another mass. That is what we call as gravitation. It's not only with the earth that earth pulls every object coming in its field. It same applies on you. It same applies on me. It same applies on sun or planets. Every mass tries to pull another mass towards itself. Every mass tries to attract another mass towards itself. Okay, beta? Is it clear? Okay, fine. Now, we studied the properties of this gravitation. The third point was the force is central. That it always attracts, that I told you. It will always, one mass will attract another mass from center to center, from the axis which is joining the center of 2 points. Yeah, two masses. Okay, beta? Fine, clear? Okay. Now we'll be moving. What is the magnitude of this force? Okay, fine. We studied that one mass will attract another mass. Fine, we're okay with it. Now the question is, with how much force will one mass attract another mass? Right, beta? Now we'll check it out. Okay, beta? If this is mass 1, m1, and this is mass m2, right, beta? It is seen that by the scientists, Newton discovered this thing. The gravitation was discovered by Newton. This is also called as the fourth law of Newton. Actually, there are 3 laws given by Newton already that are laws of motion. Right, beta? You have studied it. You will study it in 9th class. Fine. After that, there is a 4th law, which is called as law of gravitation. It's also given by Newton. Okay, beta? So the thing is, what we're trying to analyze here is that we understood that thing, that one mass will attract another mass towards itself. Fine. It will attract, it will not depend on the medium. Fine. Okay, fine. It will attract from center to center. We concluded that thing. Also, the force is always attractive. Fine. We concluded that thing. But what will be the magnitude of this force? It has been seen by the Newton that the force of gravity between two objects, between two masses is directly proportional to the product of their masses. That means when you have large mass, when you have two mass, one is larger or same, both are same, m1 and m2 are same. For example, is 5 kgs, 10 kgs, whenever there are two masses, it is seen that force of gravity is directly proportional to them. That means, what does that mean? What is directly proportional? Directly proportionality means that whenever the magnitude of two masses, for example, this is 5 kg, this is 5 kg, right? Whenever the mass is increased, the force will also increase. That means if there are two objects, 5 kgs and 5 kg, two objects having mass 5 kgs and 5 kgs, here there will be some magnitude. It is equal to the product of the masses. Fine. It is directly proportional. This will be 5 into 5 will be 25 kgs. That means force is directly proportional. If the mass is increased, now the mass is not 5 kgs, it's now 10 kgs. We have took some another mass. 10 kgs both. Right, beta? So when we product their masses, that is 10 into 10, that is 100 kgs. The force is also increasing. Now the force is equal to or proportional to 100 kgs. When you are increasing the mass, the force is getting increased. That's the meaning of directly proportional. That means whenever mass is increased, force also gets increased. And it's been seen that beta, this force is also inversely proportional to the square of their distance. What is the distance between these two? Let's represent it by r. Right, beta? Let's represent it by r. R is the distance between two masses. Fine. Is it okay? Now, beta, it has been seen that this force, whenever there is a distance is large, the force is less. Whenever the distance is less, the force is more. That means when this thing is increasing, this thing is decreasing. And vice versa. When this thing is decreasing, when force is decreasing, distance is also decreasing. What does inverse proportionality mean, beta? Inverse proportionality means that when you are raising the value of one thing, for example, here the distance is getting reduced. The object is here at some distance. Now the distance is being reduced. Now you can see here the distance is less between two masses, m1 and m2. Here distance is less. Fine, beta. Here distance is less. When distance is getting reduced, the force is getting increased, beta. Force is getting increased. That means Newton checked out that whenever the force of gravity between two masses, it is directly proportional. Whenever the mass is increased, force is getting increased. And whenever the distance is getting increased, the force gets decreased. He checked out that force is directly proportional to the product of their masses and force is inversely proportional to the square of their distance. Okay, beta? So Newton concluded with a formula which is called as the universal law of gravity. Beta, this gravitational force is equal to G m1 m2 by r square. You have put a constant here for the equality. Beta, you introduced a constant. This constant is having some value. I will elaborate it further. So you finally concluded with a formula that is F, the force of attraction between two bodies, F is equal to G m1 m2 by r square. This is the force of attraction between two bodies. Okay, beta? Now the question here is, if I am having a mass of 1 kg and I'm having another mass of 1 kg, I'm having two balls, each having mass 1 kg. Fine, beta? So why they are not getting attracted towards each other? Why they are not getting attracted towards one another? Okay, fine, beta. Let's check it out. What is happening? We recently concluded with a conclusion that whenever there are two masses, they will attract each other with some force. Right, beta? They will attract each other with some force. For example, I'm having a mass of 1 kg and I'm having a mass of 1 kg at a distance of 1 meter. The distance between these two masses is 1 kg. Right, beta? It is for sure that these two masses will attract each other. But what is the force? What's the magnitude of force that they are attracting each other? We'll check it out. Okay, beta? Let's see. We know the force of attraction between two bodies, that will be F is equal to G m1 m2 by r square. Fine, beta? I told you this G is a constant. Whenever there is a constant term, there is some value of it. So the value of G is equal to 6.67 into 10 raised to power minus 11 is the magnitude of this constant. Fine, beta? We'll find its unit after it. Okay, beta? Right now you just conclude that the magnitude of this constant is this thing. Okay, beta? Fine. But you notice one thing here, beta. This constant is having some value which is in negative form. That means it is less than 1. It's very, very, very small unit. Beta, the magnitude is very, very, very small. It's less than 1. Right, beta? You notice this thing. Now we'll see what will happen to this mass. We're having two masses of 1 kg at a distance, 1 meter separation. Fine, beta? So apply the formula. we will get force is equal to, how much is G? What's the value of G? This thing, 6.67 into 10 raised power minus 11, right beta? Into, what's the mass of another body? What's the mass of one body? 1 kg. What's the mass of another body? 1 kg. We'll put the value of M1 and M2 as 1 and 1. Fine beta? Divided by R square. What's the distance between them? What's the distance between them? It's 1 meter. That means the square of 1. Fine beta? The force will come out to be, this whole thing, this is 1, this is 1. This will come out to be 6.67 into 10 raised power minus 11. What is the unit of force beta? What is the unit of force? It's Newton. That means the force will come out to be 6.67 into 10 raised power minus 11. As you can check it out beta, this force is very, very, very less. Why is this force less? Because whatever the term is here, it's having a power of minus 11. That means it is equal to 0.00000011 times 6.67. It's very less value beta. It is very less value than 1. That means this less force, whenever two masses of 1 kg are separated by 1 meter distance, they will not attract each other much. They will attract a little force. The force of attraction here is very little. It's less than 1. So they are not gonna attract each other practically. As we checked out, when you were standing in front of me and I was standing in front of you, we tried to attract each other because the property of mass is that we are attracting each other. I'm attracting you and you are trying to attract me. But this force is so much small, beta. This is so much small that we're not able to attract each other. Okay, beta? It's so much. Definitely, the force of attraction, the force is we're attracting each other. This force is attractive in nature, beta. But its magnitude is that much small, is so much small that we are not able to attract each other. But what happens with the earth? When we are trying to understand the earth, when I drop this pen from my hand, it gets pulled towards the earth. The earth attracts this pen towards itself. What happens here, beta? What happens? Now we will check it out. Okay, beta? So we will take earth. For that thing, we must know some parameters. What is the radius of earth? What is the mass of earth? Right, beta? Let me tell you, let me inform you that the mass of the earth is 6.1 into 10 raised power 24 kgs. Right, beta? This is the mass of the earth. Okay, let it, for the sake of calculation, take it as 6. 6 into 10 raised power 24 kgs is the mass of the earth. Can anybody among you guess what's the radius of the earth? You must have heard it many times from your childhood, or a concept, an idea must have raised in your mind that how much should be the radius of the earth. Let me tell you that thing. It is, the radius of earth is, if earth is like this is our earth, from center of the earth to the circumference, that is the radius. The distance is 6400 kilometer. Right, beta? 6400 kilometer. 6400 kilometer. We will convert it in meters. Right, beta? We'll convert it in meters. This will be equal to, when you convert 1 kilometer into meter, you have to multiply by 1000. How many meters are there in 1 kilometer? There are 1000 meters in 1 kilometer. So you are converting kilometer into meter. So you have to multiply by 1000. Okay, beta? This will be 6400 into 1000. Right, beta? This will be equal to 1, 2, 3, 4, 5. 6.4 into 10 raised to power 6 meter. Right, beta? What I did, this is a huge calculation. This will be 6, 4, 0, 0, 0, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This value, I just converted it into 6.4 into 10 raised to power 6. I just converted it into a lower value. Okay, not a lower value really, but it sees like, we're converting this meter. I'm not writing this big value here. I will try to use this value. Okay, beta? So, we know the mass of the earth. We know the radius of the earth. we know that G, the constant of gravity, is equal to 6.67 into 10 raised to power minus 11. Right, beta? We know these things. So what will we do now? We'll check out why, for example, I gave you the example of this pen. Why this is getting pulled by the earth. We'll take this pen. Okay, beta? Okay, I will take a ball first of all. Right? I will take a ball of 1 kg. The mass of this ball is 1 kg. And earth is very big. Very big, beta. What's the mass of the earth? It is near about 6 into 10 raised to power 24 kgs. 6 into 10 raised to power 24 kgs. Okay, beta? This mass, this 1 kg mass is lying somewhere on the earth. Right, beta? Near to the surface of the earth. Right now, I am standing on earth. If I am having a mass of 1 kg in my hand, right, I will drop it. It will get pulled towards the earth. Why will this thing happen? We'll check it out, beta. You tell me, what is the distance from the center of the earth to this point? You can take this mass on the surface of the earth, because the distance here is so much large, beta. It's 6,400 kilometer. In 6,400 kilometer, 1 meter will not matter. You can take it on the surface of the earth. Right, beta? So right now, we know the distance between two masses. Here, this is M2 and this is M1. Right, beta? This is M1 and this is M2. And the distance between them is 6,400 kilometer. Right, beta? This is mass M1. This is mass M1. That is mass of the earth. And this is mass M2, mass of the ball. Okay, beta? Mass of ball, I will represent it by MB. Right, beta? And the distance between them is how much? 6,400 kilometer. We have already converted it into meters. Now we'll check out by which force earth attracts this 1 kg mass. Right? You know the gravity is the force of attraction between two masses. Right, beta? Now, what is the magnitude of that force? We'll find out. We have formula. We have formula that is F is equal to G M1 M2 by, say it, R square. Right, beta? So give the values. You know how much is G? G is, how much is G? G is 6.67 into 10 raised to power 11. Right, beta? The constant here is the value of constant into what is the mass M1? What's the mass of earth? It is 6 into 10 raised to power 24 kgs. Right, beta? And what is the mass? What is M2 here? 1 kg. Right, beta? Divided by what is the distance between them? Is 6,400 kilometer. Let's write it as in meters. That is 6.4 into 10 raised to power 6. But you know one thing, beta, it's R square. So we have to square this thing. Right, beta? It is clear, right? So what are we going to do now? These terms, 10 raised to power something, 10 raised to power something, 10 raised to power something, we'll keep them separate. And these values, we'll evaluate them. This 6.67 into 6, this will be something around, beta. This will be something around 40. When we multiply 6.67 into 6, it will be 39 point something. Let's, for the sake of calculation, took it as 40. Okay, beta? This is 40 into 10 raised to power 11 minus 11 into 10 raised to power 24. Right, beta? Divided by, here 6.4 into 6.4. There is a square. You have to square both of the terms. 6.4 into 6.4. This will come around 40. Okay, beta? This will come around 40. The distance 6.67 into 6.4 into 6.4. This will come out, nearly come around 40. For the sake of calculation, take it also as 40. Fine, beta? You squared this term. Now is the chance of this term 10 raised to power 6 whole square. That will be, when bases are same, powers are added. This will be 10 raised to power 6 into 10 raised to power 6. When bases are same, powers are added. This will be into 10 raised power 6 plus 6 is 12. Okay, fine beta, it's clear. Now see it. I will try to solve it now from here. Okay beta? Yeah, I have took these values. I don't need them anymore. So the value comes out, this 40 and this 40 will cancel out. Okay beta? Now the term here is F is equal to 10 raised power minus 11 into 10 raised power 24 divided by 10 raised power 12. Right beta? What will we do? The term in the denominator, when it's raised in numerator, it will get a minus sign. If it is 10 raised power 12, you have studied it in math, right? When it's in denominator, we will multiply it. It will go up, but with a minus sign in the power. 10 raised power 12 will be equal to, it was 10 raised power 12 here. Now it will be written as 10 raised power minus 11 into 10 raised power 24 into 10 raised power minus 12. Here it was positive. Now it will be written as negative. Right beta? So beta, as you are checking it out, when bases are same, powers are added. 10 minus 11 into 10 minus 12 into 10 raised power 24. This is the term. When bases are same, powers are added. Minus 11 plus minus 12. This will be 23. This will be 10 raised power minus 23 into 10 raised power 24. 10 raised power minus 23 into 10 raised power 24. When bases are same, powers are added. These two terms will add out. This will be 10 raised power 24 plus minus 1. That will be 24 minus 23. That will be only 1. 10 raised power 1, that is equal to 10. That means the force we got here is 10 newtons. That means the 1 kg mass, 1 kg ball was experiencing a force of 10 newtons towards the earth. So will it get attracted towards earth? Definitely. The earth is trying to attract it by a force of 10 newtons. Right beta? So whenever I take 1 kg ball in my hand and I drop it, it simply falls down because earth is attracting it with a force of 10 newton. And one thing more beta, if there's a 1 kg ball in my hand, why this is not getting attracted towards myself? Why it's getting attracted towards earth? Because beta, earth produces a large force. The magnitude of the force is 10 newton and the force I am exerting on this mass is very less. We just checked it out. It was less than 1. It was 0.0000 times. It was very less force. So the effective force will be by the earth, that is exerting a force of 10 newtons on it, and I am exerting a little force on it, very little, negligible force on it. So definitely it will get attracted towards the earth. So you got the concept beta. You got the concept why the things fall on earth, why I can't attract you. Why whenever you are taking a phone, when you are having a phone in your hand, you are trying so much that it should not fall down and its tempered or display should not break. You are trying that thing. You have tried many times that thing. But simply when you do anything, you are just playing or something, the phone skips from your pocket or hand, it falls down. Because earth is exerting more force on it than you do. Hope this thing is clear beta. Next time we'll be coming with a good topic. Same topic we will continue and we will try to analyze the things and universe around us. So beta, keep working hard. This is the first step to prepare for your NEET examination and JEE examination. So right from here, right from 9th class, you have to try your 100%. You have to give your best shot so that the results will be best. Thank you so much and best of luck.